All right, so I think this is recording. Let's take a look at solving these two equations. They are quadratic in form. You may not be able to see that the way it's written now. So we're going to let's rewrite both of these. If we rewrite this first equation, if I move the term 18x to the negative fourth as the first term, and then plus 21x to the negative second power, subtract 9 from each side is equal to 0, I can see that this variable x has an exponent of negative 4 here, and half of negative 4 is negative 2, so we say this is quadratic in form. Now, I've also noticed as rewriting this that all of these terms are divisible by 3, so we can reduce these values. So 18 divided by 3 is 6. 21 divided by 3 is 7. 9 divided by 3 is 3, and 0 divided by 3 is 0. So let's do our change of variable. Let's let u equal this x to the negative second power, and then by squaring both sides of this equation, u squared is x to the negative fourth power. So now by a substitution, changing the variable from x to u, we can rewrite this equation as a quadratic equation. 6u squared plus 7u minus 3 is equal to 0. And let's see if we can factor this. If we can't factor it, we know we can use the quadratic formula. You've learned in previous Algebra 1 classes a technique for factoring polynomials as the x method. If we multiply the first term times the last term and put that in the top of our x, the middle term here is at the bottom of our x. If we try to come up with two values and multiply together, give us the top, but when added together, give us the bottom. Positive 9 and negative 2 seem to do the trick. I'm going to shrink this up, and then we can continue to try to factor this now in the form of a table. The table is just a nice way to apply the distributive property. It gives us an organized way to attack the problem. So in this 2x2 table, along one diagonal, we write the first term and the last term of the original equation, and along the other diagonal, we write the what we found from our x method, and we now factor this horizontally and vertically. I can see that I have a negative that's common to both here. These are both divisible by 3. These are both divisible by not only 3 but by u, and here this is divisible. These are both even and divisible by u. So now I can check that 3u times 2u is 6u squared, that 3u times 3 is 9u, that 2u times negative 1 is negative 2u, and that obviously negative 1 times a positive 3 is negative 3. So this table now helps me to rewrite this trinomial as a product of two binomials, and now it's pretty easy to solve this equation. See, before, without factoring it, it'd be very difficult to just look at that and do it in your head, although some people might be able to, but I certainly can't. This splits into two equations. We've got 3u minus 1 could be 0, or that 2u plus 3 could equal 0. Each of these in two steps, you can have the equation, or have the solution here. If I add 1 and divide by 3, and here if I subtract 3 and divide by 2. But remember, my original variable was x, not u, so I need to come in and replace this u with x raised to the negative 2 power. That's equal to 1/3, and here x to the negative 2 power is equal to negative 3/2. Well, over here we have a problem that that's never going to be a true statement. There's no way that x to the negative 2 power would ever result in a negative number. Yeah. Okay. There. So remember that a negative exponent doesn't make your answer negative, that a negative exponent simply changes the location of that base within a fraction. So if I didn't notice that this x squared, that this is never going to be a negative value, suppose now I just continued and I'm trying to solve for x, I cross multiply, I have negative 3x squared is equal to 2. I have x squared is equal to negative 2/3. Now here, warning signals should definitely be going off. How could you take a number and multiply it times itself, and how can it ever be negative? This gives us no solution. Okay, now over here, however, this x to the negative 2 power, if we write that as 1 over x squared, now the 1/3, it didn't have any negative exponents. It just stays 1/3. If I cross multiply here, you can see that I get that x squared is equal to 3, or that x is positive or negative square root of 3. So here's my solution to this equation. Like I say, this provided that when this split into two equations, this u to the negative 3/2 power was not a solution for the original equation. It was a solution for the equation that had this variable u, but not the original. All right, so let's take a look at this next problem. And again, maybe let's rewrite this. This 1 over x squared, I can make this x over 1. I can change the location of that base within a fraction if I just simply change the sign of the exponent. So 1 over x squared can be rewritten as x to the negative 2nd power, and minus 3, this 1 over x can be rewritten as x to the negative 1st power. And now you can see maybe a little bit easier that this is quadratic in form, that half of negative 2 is negative 1. So by a change of variable, I can let u be this x equals negative 1, which means that u squared is x to the negative 2nd power. I can rewrite this equation as u squared minus 3u plus 2 is equal to 0. And this factors pretty easily. I think you can see that it factors to u minus 2 times u minus 1. This gives us 2 or 1 as solutions to this equation. But remember, we need to replace u with x to the negative 1st power. Write that. Or you know, what you could do is raise each side to the negative 1st power. And a power to a power, you multiply the exponents. Negative 1 times negative 1 is x. 2 to the negative 1st power is just 1/2. And over here, x to the negative 1 is equal to 1, and that's pretty easy to see that x is equal to 1. So here's our two solutions for that. So hey, I hope that helps, and I'll talk to you later.